Welcome to True Projects. In this video, we are going to explain about a project titled Ensemble-based Deep Learning Model for Network Traffic Classification. So now coming to the introduction part. In today's digital environment, the classification of network traffic is crucial for maintaining the security and optimal performance of computer networks. As network services continues to grow and the patterns of network traffic become more intricate, there is a growing need for advanced methods that can precisely recognize and categorize various types of network activities. To address this ever-evolving challenge, our study presents an ensemble-based deep learning model created with the aim of improving the classification of network traffic. So now coming to the objective part for this project is to notably enhance the precision of network traffic classification. As network activity becomes more diverse and intricate, conventional methods often face challenges in disconcerting legitimate from malicious traffic. Second, here we have strengthening resilience and flexibility. So in this, the research aims to bolster the resilience of network traffic classification. Given the dynamic and constantly evolving nature of network threats, there is a need for models that can adapt to new attack tactics. So now coming to the requirements part, here we have two types of requirements, that is hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset. In this step, you examine the dataset to understand its structure, features, and contents. You will typically check for data types, missing values, and basic statistics to gain insights into the data. Next, here we have data processing. Using Pandas data frame for ML. Pandas data frame is used for data manipulation and preparation, which can involve tasks such as cleaning and coding categorical data and feature engineering. Second, we have using Keras categorical for deep learning. Keras may be used for deep learning, especially for categorical data handling, feature selection, and preparing the data for neural networks. The next year we have visualization using Seaborn and Matplotlib. This step is focused on visualization. Seaborn and Matplotlib are employed to create plots and charts that help in understanding and presenting the data. It may involve displaying sample outcomes, creating comparison visuals, and plotting learning graphs. Then next year we have feature selection X and Y using Pandas iLog. Feature selection involves choosing the relevant features for your analysis and modeling. Pandas iLog is used to select the input X and output Y features. Then we have splitting the data to train and test. To evaluate the model's performance, you divide the data set into two subsets, a training and a testing set. The training set is used for building the model, while the testing set is used for evaluating its performance. Next here we have building the model. In this step, you create machine learning and deep learning models. You list various models that may be experimented with, including ensemble methods like random forest, decision tree, AdaBoost, and XGBoost, as well as deep learning models like convolutional neural network and hybrid models like CNN plus LSTM. Voting classifier combines multiple models, example SVC, random forest, decision tree, to make the predictions based on their collective results. The next year we have training the model. Train the machine learning models on the training data to enable them to learn patterns and relationships within the data. Next year we have building the model with voting classifier. It seems that building a model with a voting classifier is a separate step from individual model learning building. Then voting classifier combines predictions from multiple models to improve prediction accuracy. Next year we have Flask framework with SQLite for sign up and sign in. Integrate the Flask web framework with the SQLite database for user registration and authentication, creating a web interface for users. Next year we have user gives input as feature values. User provides input in the form of feature values that the model will use for prediction. Next we have the given input is pre-processed for prediction. Pre-process the user's provided input, ensuring it's the correct format and scaling it as needed for the model. Then we have trained model is used for prediction. Apply the trained machine learning or deep learning model to the pre-processed user input to make the predictions. And the final outcome is displayed through front-end. Present the model's prediction or analysis result to the user through a front-end interface, which is typically a web application, making the insights or predictions accessible and user-friendly. So here you can see that we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Another folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Next we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path, open the Anaconda prompt, type the cd command followed by a space and the space the path over here, and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the Ensemble based deep learning model for network traffic classification. There is a button for sign up. Just click on this button. Enter your username, name, email ID, phone number, and a password over here for doing registration. I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration and simply click on submit button. So here you can see that we have to enter the date time. Here we have to enter the latitude, then longitude, direction, enter the road. Here I am entering A1, vehicle speed 1, vehicle flow rate as 5, and traffic concentration as 4. And now simply click on submit button. Okay, so here we have to enter the time also, 07:29. And now simply click on submit button. So you can see it is showing the outcome based on the speed and vehicle count. The network traffic is congested. So depending upon the parameters you are providing over there, it will showing the outcome whether the speed of the vehicle count, the network traffic is congested or not. Here you can see that there is a button for about. Just click on this button. And here you can see that there are many different graphs where we have used many different algorithms, and based on these algorithms we have got the accuracy, precision, recall, F1 score. So here you can see there is a button for sign out. By simply clicking on this button we can successfully log out with this. So now coming back to the conclusion part, this research has effectively presented an ensemble-based deep learning model which showcases significant improvements in the precision and resilience of network traffic classification. The integration of deep neural networks in the ensemble method has demonstrated exceptional performance in identifying intricate patterns, minimizing erroneous identifications, and elevating the overall accuracy of traffic classification. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.